Okay, this is chapter 2 on ratio, rate, and proportional reasoning. This is your practice test from the textbook. And the first few questions are multiple choice. It says the ratio of Jared's stamps to Paulo's stamps is 4 to 7. If Jared has 36 stamps, how many stamps does Paulo have? So what we're really doing here is we're doing a part-to-part ratio of Jared to Paulo. Now, if you want to, you could do it Jared to Paulo. But we said when we were studying section 2.1, you have to know that if you use fraction form for ratio notation, you have to be aware of whether that fraction form is actually a part-to-part ratio or a part-to-whole ratio, because you can still use, for part-to-part ratios, you can still use fraction notation, but you have to be aware that it's not a fraction. It just looks like one, right? So if I was to write Jared to Paulo's, I know it's 4 to 7, or I could put down here 4 to 7. All right. If Jared has 36 stamps, how many does Paulo have? Or if Jared has 36 stamps, how many does Paulo have? Both of these ways that we've written it are really ways of answering the same question. And if we look at the second way using fractions, we understand from all of our experience here, we could do it 3 ways. We can solve that particular ratio, the missing value in the ratio, 3 ways. We could identify what we multiplied 4 by to get 8 and multiply there, and therefore we'd say x equals 56, and therefore Paulo has 36 or 56 stamps. Paulo has 56 stamps. How many did it that way? Most of you probably did it that way, right? Because you acknowledge that's the easiest way to do it. However, it's not the only way you could have done it. If you set it up this way, another way you could have done it is you could have said, well, if Jared has 1 stamp, meaning I'm going to say, well, for every 1 stamp that Jared has, right, dividing it by 4, and 7 divided by 4, if I grab my remote real quick, 7 divided, oh, that's not 7. 7 divided by 4 means that for every 1 stamp that Jared had, Paulo has 1.75 stamps. And then if he has 36 stamps, I would just multiply 1.75 by 36, multiply 1.75 by 36, and it's 63, right? That's a modified version of, did I make a mistake there? No. A modified version of, that's a unit rate modified version. And the other way you could have solved it, of course, is what? What's the other way you could have solved it? The easy one, what's that called? Cross multiplication algebraic method, whatever you want to call it. And I could have multiplied across here to get 4x, multiplied across here to get 210 plus 42 is 252. 252. Divide both sides by the coefficient of 4 and isolate it algebraically. And 252 divided by 4, does anyone want to guess what it is? Of course it is. X equals 63. So the important thing for me to say there is you could solve that based on the fact that you now understand proportional reasoning. If you set it up as a proportion, you could definitely solve that question any number of ways. I'm assuming most of you solved it the first way, just multiplying Jared's total by 8 and Paulo's by 8 to get, oh sorry, 9. Did I say 8 last time? Yeah, 4 times 9 is 36, now 4 times 8. Good. Your second question says a robot can make 27 toy cars in 9 minutes. What do we call 27 cars in 9 minutes? What is this actually, if I write it like that? What is that? It's the rate. It's the rate at which the robot can make cars. 27 cars in 9 minutes. But it then says which of the following is the unit rate for this robot. And we know that a unit rate means how many robots can it make in 1 unit. Now we could have said 1 hour, really. I could have multiplied 9 minutes, or brought it down to 1 minute and then multiplied it by 60. And that would be how many robots it or how many cars it makes per hour. Or I could do per day by multiplying it by 24 if the robot never stops. But per minute is the most efficient. We know that the best way for us to use this is dividing by 9. And I got 3 robots per minute is my unit rate. And therefore, the appropriate unit rate would be 3 cars per minute. Question 3, in the school choir, the ratio of girls to boys is 17 to 8. So there's 17 girls to boys. It's girls to boys are 17 to 8. Now we know what kind of ratio is this. It's a part-to-part ratio. And since the question is asking us what percent, those of us who are very familiar with this are going, you can't make percents from part-to-part ratios. But it says what percent of the school is boys? So there's 8 boys in the school choir, how many total students, or what's the total number in terms of combined uh, terms that would be expressing all of it in that choir? The answer is 25, right? There's 25 uh, parts to every 8 boys. There are 25 total students. And from this, there's two ways you can really do it. You could say that 8 out of 25 is equal to 1 out of 100. And the reason why I'm making it an equivalent fraction out of 100 is because percentages are expressing out of 100. Multiply both by 4, you get 32, and therefore 32% are boys. Another way to do it is to change your fraction to a decimal by dividing the numerator by the denominator. And if I divide 8 by 25, I get 0.32. And if I read this number, what number is that? Not 0.32. That's what it looks like. What number is it, Cohen? 32 hundredths. And when I say 32 hundredths, that's what I mean when I say 32 hundredths. So you can then go up to here and then over to your 32% as the answer. So therefore the answer is D, 32%. Question 4, we could skip. Question 5, it says a currency exchange requires 500 Canadian to receive 600 Australian. When you see that, if I showed you that question 3 months ago, none of you would think about solving it using proportional reasoning, right? Now what we're trying to do is we're trying to ingrain in you that number sense that says, you know what, I can solve this proportionally. I can make a proportion here. So the proportion I'm going to make is a ratio, or is a comparison of Canadian to Australian, right? A ratio of Canadian to Australian. So for every 500 Canadian, you will get 600 Australian. That's the ratio. Therefore, if you have 300 Canadian, how much will you get Australian? Again, there's many ways you can do it. I'm going to show you, I'm going to take this and I'm going to write it over here. And why I'm doing that is I'm going to say, well, hold on. For every 100 Canadian dollars, how many Australian dollars do I get? I'm going to do it that way. And I'm going to do it by dividing both terms here by what number? 5. When I do that, 600 divided by 5 is 120. And then once I get there, I can then reconfigure it by multiplying both by 3 and solve x as being 360. That's one pathway. Who did it that way? Anybody? Cohen did it that way. Allison did it that way. Okay, a few of you did it that way. Another way you could have done it is go 500 over 600 equals 300 over x. What did you divide 300 or 500 by to get 300? Right? So let's think of an easier question first. Let's put 10 and a smaller number of 2. What did I divide 10 by to get 2? 5. How can I get that? How do I get what I divided it by? I can take this number divided by this number will tell me this number here, correct? So therefore, 500 divided by 300 tells me 1.6 repeating. So once I see that, I'm like, oh, that sucks, because that's going to be really tough to work with. So I don't like that method. But there's a third method. What's that third method going to be? The algebra. And we got this simple one here that's going to be 500x is equal to 180,000. If you divide 180,000 by 500, you get the exact same thing you need to. 180,000 divided by 500 is 360. Okay. No matter how you did it, you get $360 Australian. Question 6 says Canadian buys, I don't believe this stat, buy 5 loaves of brown bread for every 2 loaves of white bread and 1 loaf of rye bread. I know that white bread is much more popular to buy than brown, but whatever. So the ratio is really a 3-term ratio. It's brown to white to rye. So if I write it as a 3-term ratio, it's 5 to 2 to 1. If I then put in a large bakery makes 20,000 loaves of brown bread, how many of white and how many of rye, all I have to do is find out my multiplier in my 3-term ratio, and in this case it's 4,000. So 5 times 4,000 is 20,000. So if I multiply all of my terms here in my 3-term ratio by 4,000, I will keep my number of loaves of bread made proportional to each other, which means I have 8,000 white and 4,000 rye. Okay, any questions on that? Everybody did it kind of like that? Maybe? Okay. Question 7 says Randy made 9 scarves from 4 meters of fabric. How many scarves can she make from 28 meters of the same fabric? So here we're going to do a rate of scarves to meters of fabric. Scarves to fabric. So 9 scarves from 4 meters of fabric is proportional to how many scarves can she make? How many scarves means I don't know it from 36 meters. Looking at that proportion, what's the easiest way to solve it? Oh, 28, sorry. Thank you. What's the easiest way to solve it? Algebraic, division, multiplication, or unit rate? Multiplication. 4 times what is 28, Cohen? Right. So if I multiply both by 7, I figure out that I can make 63 scarves from 28 meters of fabric. Your answer is 63. Question 8. Uh, it's kind of like it's the same thing as proportional reasoning, but there's like a half a step added to it to kind of make you confused a little bit. It says there's tank A and there's tank B. Tank A has a capacity, if it was filled, of 20 liters, but it's not filled, is it? It's only half filled. So how many liters are in here? 10 liters of maple syrup. It says the ratio of volume capacity of tank A to tank B is 2 to 5. So if I put tank A to tank B is 2 to 5. That's the ratio. For every 2 parts that are in tank A, there are 5 parts in tank B. Or for every 2 liters in tank A, there are 5 liters in tank B. So therefore, if tank A has 10 liters, how many in B? Of course, we're going to just solve this with multiplication. How many are in B? There are 25 liters in tank B. Using proportional reasoning to solve. Question 9, again, it's kind of like a little added step here. It's like, do you understand how to get fractions of numbers? The circle graph shows the favorite pets for a class of 32 grade 8 students. So how many students selected a pet other than a dog, a rat, or a cat? Or dog, cat, or rabbit? If 32 students are in the class and half like cats, that means 16 like cats. A quarter of 32 is 8 students, and an eighth of 32 is 4. If I add those together, that's 28, which means 4 students like other. It says write the ratio to represent the number of students who selected a cat to rabbit. So cat to rabbit. Cat is 16, rabbit is 4. With this ratio, what probably, it didn't say to do it. Oh, yes, it does. It says write an equivalent ratio. What can we do with this ratio that will make an equivalent ratio, Hannah? What are we actually doing when we divide both terms by 4? We can actually say, using our mathematical terms, that we're reducing the ratio to lowest terms. Just like we would say we're reducing the fraction to lowest terms, we're reducing the ratio to lowest terms. That means for every 4 cat lovers, there's a rabbit lover out there. One of them. Question 10 says the lengths of A, B, and C are in the ratio of 8 to 2 to 3 respectively. The A to B to C, the ratio is 8 to 2 to 3. That means for every 8 meters of length, it's 2 meters of width and 3 meters of height, or whatever you want to say. If the length of side C is 24, what is B? What is A? Easiest way to solve this is figuring out what your multiplier is for C. What did you multiply C by to get A? Or, sorry, 24. You multiply it by 8. Just like the bread question, do all that, you get 16 and 64. But we're not done yet, are we? The question says, what is the area of the top of the box? So in this one, the top of the box has a length of A and a width of B. What is the length of A? Well, we just solved it as being 64 centimeters. What's the width of B? It's 16 centimeters. How do we get area of a rectangle? Multiply length times width. So over here, we're going to put formula area equals length multiplied by width, or 64 multiplied by 16. Should be easy to do. I think that's 1024? Oh, I knew that. 1,024. So therefore, the area is 1,024 centimeters squared. Question 11 says Kira is shopping for ketchup. Her favorite brand is available in 2 sizes. Estimate which is a better deal. Okay, so I talked to one student who is often confused, and she said she is going to find the ratio of volume to dollars. And I didn't argue with that student because you know what, you can do that. And whatever you get, whatever volume you get for $1 is going to be the better deal. But generally speaking, the better ratio is to find money to volume, and that's the one we're going to use. If you use the other one, that's fine. It's not wrong. But you got to be smart about it. So for the small one, it's $2.09 for 500 milliliters. For the large one, it's $3.29 for 750. Now, if we compare them, do we have to do a unit rate out of 100? No. Do we have to do a volume out of 1,000? No. Do we have to do a volume out of 1? No. I'm going to be different. I am going to see the cost of how much volume, do you think? No, I'm not going to do for $1. What volume of ketchup am I going to use? I'm not going to use 100. I'm not going to use 1,000. I'm not going to use 1. What do you think? I'm going to figure out what the cost is per 250 mils. Why did I choose 250? Because I know that both 500 and 750 can be divided by whole numbers to create 250. So if I can compare the cost for 250 mils of ketchup rather than 100 or a liter, I still am able to determine what the best deal is, right? So I'm going to use, and we could do 100 too, because you could divide this by 7.5. But I'm just looking at saying I'm going to be different. I'm going to divide both by 2. Gives me $1.04.5 per 250 mils. That's, by the way, that's $1.04.5 right there. Here I'm going to divide by 3, and that's going to be a dollar. Uh-oh. Uh-oh. I think it's a repeating decimal. Yeah. 1.096 repeating cents per 250 mils. Now can I compare them? Yes. Which one's the better deal? The small is. This one here is a better deal, isn't it? Why? Because it costs me less money to buy 250 mils of that ketchup, right? A quarter cup of that ketchup, or a cup of that ketchup, a quarter liter. Okay. Question 12. Pita runs 200 meters in 30 seconds, while his sister Eva runs 300 meters in 36 seconds. Who is the faster runner? How many did distance to time? How many did time to distance? You did per 100 meters or per second? Per second. So we want time on the bottom. So we're going to put our rate is going to be distance to time, meaning 200 meters to 30 seconds. We're going to figure out how far they went in 1 second. So I'm going to divide both top and bottom term by what number? 30. To create that unit rate. 200 divided by 30, it's going to be a repeating decimal as well. It's 6.6 repeating. So therefore, Pita runs 6 2/3 meter per second, which is roughly that distance right there from wall to wall. Eva runs 300 meters in 36 seconds. Divide both by 36. 300 divided by 36 is a terminating decimal. No, it's not. It's repeating. Oh, my God. Is that right, by the way? 8.3 repeating? 8.3 repeating meters per second, or 8 1/3 meters per second. Who's faster? Eva. Eva can run a greater distance in a second, so therefore, she's faster. Correct, Vietnam? Correct. It then goes on to say, at the same rate, how far will each runner go in 2 minutes? What will I do to figure out how far they go in 2 minutes? Multiply both by what? 120, because there are 120 seconds in 2 minutes. So, I wish my calculator, I'm going to do this one down here first, because I already have it built into the calculator. Multiply this by 120, I get 1,000. 1,000 meters in 2 minutes. What does that really mean? What's 1,000 meters better known as? A kilometer. So Eva can run a kilometer in 2 minutes, whereas the slower brother, 6.6 repeating, multiplied by 120, is 800. 800 meters in 2 minutes. So if both of brother and sister ran for 2 minutes, Eva would be 200 meters ahead of the brother after 2 minutes. Question 13, it says, each week Karen, oh, there's a name that's become popular in the last couple of years. What a Karen. Karen earns $420 for 35 hours of work at a factory. Her friend Liam makes $440 for 40 hours of work at the same store. Who has the greatest hourly rate of pay? So hourly rate of pay. Hourly means per hour, which means our time is our bottom. So the rate that we're going to create here is salary to time, or $420 to 35 hours, or for 1 hour, divide both by 35. 420 divided by 35 is 12. Therefore, Karen makes 12 bucks per hour. Liam makes 440 for 40 hours. Divide both by, sorry, I forgot to do that. So you divide both by 40. Liam would make $11 per hour, and therefore Karen has the greater hourly rate of pay. How much does Liam earn for an 8-hour shift? If you take this and multiply it by 8, he makes $88 for an 8-hour shift. And finally, our last question, question 14, says the actual height of a goat, the greatest of all time goat, shown here is 1.14 meters. Measure the height of the goat in centimeters. Oh, I forgot that one. Okay, you can't do 14. I can't do it because I can't measure it. How high is the goat? Did anyone measure it? Don't worry about it. We're done.